Hello, and welcome to lesson 7.3, finding area and perimeter. So we're going to start out with just some basic shapes, and then we'll work into some that are a little bit more complex. So our first one is finding the perimeter of a rectangle. It says you want to trim a rectangular frame with a metal strip. The frame measures 30 inches by 20 inches. Find the length of the metal strip that you would need to trim the frame. So there's a rectangle already drawn here for you. So if you take a look, go ahead and draw it on your paper. The length is 30 inches and the width is 20 inches. Now in a rectangle, hopefully you remember this from previous classes, the opposite sides are congruent or the same length. So we can go ahead and fill in those two measures. And the perimeter of an object represents the outside and it is a distance. So we would also use this if we were finding the amount of fence we would need for a yard, etc. So the formula for perimeter is 2 times the width plus 2 times the length. Or we can just add up the numbers all the way around. The reason it's 2 times the width is because there are 2 20s, and 2 times the length because there are 2 30s. Again, perimeter is the distance around an object. So we also could just add up the numbers all the way around. Either way, you should get the same answer of 100 inches. A rectangle is our first shape. Our second shape is a square. The biggest thing to remember about a square is that all 4 sides are the same length. And of course, there are 4 right angles in both a rectangle and a square. But this one side is measured as 60, so the other 3 will also be 60. Our situation for this one says find the length of fencing to surround a square corral that measures 60 feet on each side. Again, we could use the same formula we did for the rectangle, just knowing that the length and width are the same. Or we can use the perimeter of a square formula, which is 4 times S, or the side length. So 4 times 60, or 240 feet. Again, perimeter is a distance. All of these formulas, if you don't get them written down while we're taking our notes, are in the ebook that you can go through and get those written down. You will, of course, need to know those for the test if they will not be provided. All right, we're now going to switch gears and talk about circles. And in a circle, we want to keep in mind things we already know. The center is the point in the middle. From the center to the edge of the circle is the radius. And then through the center all the way across is the diameter. The distance around a circle is called the circumference. So if we want to find the circumference of a circle, the formula we're going to use is circumference equals pi times diameter. And we want to keep in mind that if we are doing our Cengage homework, if we want our answers to match up, we want to use the pi button on our calculator and make sure that then we round it according to what they've asked in the question. So for this particular problem, it says, find the circumference of a circle. with a radius of 15 centimeters. Then round to the nearest hundredth, which is 2 decimal places of a centimeter. So we start out by writing our formula. And they've given us the radius. So if the radius is 15 centimeters, what would the diameter be? Remember, the radius is halfway across. The diameter is all the way across. We just multiply by 2 to get the diameter. So again, we're going to use the pi button on our calculator, and then we're going to multiply by 30. I'm going to grab my calculator. I do hope as we're going through these notes that you are trying each problem also so that you have some practice as you are preparing. So if I take the pi button times 30 on my calculator, I get 94.24777,961. And if we want to round it to hundredths place or 2 decimal places, then we look to the number after. It is over 5. So 5 or higher, we round up. So 94.25. And again, it is a distance. So centimeters will be our label. The next one is going to be an application of the circumference of a circle. And you'll notice that I have a picture of a bicycle. Bicycle tires would represent circumference if we're talking about how many feet or inches or miles that it would have traveled. So let's go ahead and take a look. A bicycle tire, it says, has a diameter of 24 inches. And we're going to find how many feet the bicycle will travel if it makes 8 revolutions. And again, we're going to be rounding to the nearest hundredth. Hopefully, the first thing that popped out at you is that our diameter is in inches and our distance is measured in feet. So we want to go ahead and change it so that our diameter is also in feet. Well, hopefully you recognize the fact that 24 inches is 2 feet. If not, you need to remember that there are 12 inches in a foot. So I'm going to use 2 feet for my diameter in the problem. So again, the circumference is going to equal pi times 2, grabbing my calculator, pi times 2 is 6.283185307. And this is now in feet. Well, we're going to be making 8 revolutions. So I'm going to just leave that number on the screen of my calculator and then multiply by 8. You don't want to round until the very end. Again, especially since our homework is self-grading, if you round too early, you might be off by 1 decimal place and then you would miss the problem. So rules of math, wait and round at the end. Again, just leave this on the calculator screen and then you can just multiply by 8. Again, we're multiplying by 8 because there are 8 revolutions in the problem. All right, so we want 2 decimal places. 5 or higher, we round up. So 50.27 feet. Now, in some cases, rounding at different times might give you the same answer. In other cases, it won't. So again, please do remember the rule of thumb of waiting till the very end to round. We're just going to keep going through different shapes with area and perimeter for today. Our next one we're going to do is going to be the area of a rectangle. We started out with the perimeter, and we're going to change now to area. Area is the amount of space something occupies. Oftentimes, when we're talking about area, we're talking about rugs, carpet, tile, etc. in a real world situation. So this question says, how many square feet of sod would be required to cover a football field? And then it tells us a football field measures 360 feet by 160 feet. Please get in the habit of drawing a picture with each problem so that you can see it as you get started. Again, this is the length and this is the width. The area of a rectangle formula is length times width. They're both in the same dimension, both in feet, so we don't have to do any conversions. So we just plug in 360 times 160, and hopefully you get 57,600 feet squared or square feet. You can use either label for area, but again, we're talking about how many square feet will fit inside of this football field. So think of square tiles and how many of them we would need. So we would need 57,600 1 foot by 1 foot square tiles of sod to cover a football field. All right, our next one is going to be the area of a square. Again, with perimeter, we notice that a square and a rectangle were the same, except the square has all 4 sides the same. Similarly, with area, we're going to notice the same thing. We have a square with all 4 sides equal. Again, a square and rectangle have 4 right angles. And our formula could be length times width, where length and width are the same. Or we can do side squared or side times side. In this scenario, a homeowner wants to carpet the living room. The floor is a square and it measures 6 meters on each side. And we need to know how much carpet to purchase. So 6 meters on each side of our square. And then we are just going to square the number 6. Or again, remember that that means 6 times 6, or 36 meters squared, or again, square meters. You're going to see both in different scenarios. You need to know both ways to write your labels. Our next one is finding the area of a parallelogram. A parallelogram, hopefully you remember, just looks like a squished or squashed rectangle. So visually, if I were to cut off this triangle right here, I could move it over here. And area-wise, I would then have a rectangle. The same amount of space is going to be covered by a parallelogram as a rectangle. So our area formula is base times height. This is my base, and this is my height. Now think about where that height came from. That is this height of this triangle that I cut off. So it says a solar panel is in the shape of a parallelogram, and it has a base length of 2 feet and a height of 3 feet. Find the area of the solar panel. So again, we're just going to multiply those two numbers and get 6 feet squared or square feet. Again, if I move that triangle to the other side, the amount of space that is covered is the same as if it were a rectangle. All right, let's switch gears and talk about triangles. Triangles, we've talked about the angle measures. We've talked about length. And now we're going to look at area. The formula for the area of a triangle is 1/2 times the base times the height. It says a riveter uses metal plates that are in the shape of a triangle that have a base of 12 centimeters and have a height of 6 centimeters. Find the area of one metal plate. Again, draw your picture first. The height is 6 meters. The base, or sorry, centimeters is 12 centimeters. Height 6 centimeters, base 12 centimeters. We use our formula 1/2 times the base times the height. So we have 1/2 times 12, which is 6. And then 6 times 6, which is 36. Again, you can use your calculator if you need to. So 36 centimeters squared or square centimeters. So in this case, what you're visualizing is a square that is 1 centimeter by 1 centimeter, and that it would take 36 of them to fill the triangle. All right, our next shape we're going to find the area of is called a trapezoid. Trapezoids can look lots of different ways. I'm going to draw a traditional trapezoid, and then I'm going to draw a right trapezoid. So the definition of a trapezoid is that we have opposite sides that are parallel. And then we also have another set of opposite sides that are not parallel. So this is going to be your visual for a trapezoid. And our formula is 1/2 base 1 plus base 2. Notice I'm putting that in parentheses, times the height. So this is base 1, this is base 2. And again, our height is the height if I were to draw in this dotted line for the triangle. I'm labeling both diagrams. So regardless of which shape, the process is the same. So our scenario says a boat dock is built in the shape of a trapezoid with bases that measure 14 feet and 6 feet and a height of 7 feet. Find the area of the dock. Again, I've just labeled them on this top diagram. So we're going to go ahead and plug in those numbers. Base 1 is 14, base 2 is 6, and our height is 7. Again, notice that base 1 and base 2 are inside the parentheses. I want to add them first. Order of operations inside the parentheses occurs first. Then we can multiply from left to right. 1/2 of 20 is 10. 10 times 7 is 70. Again, feet squared or square feet. All right, our last examples are going to have to do with area of a circle. We've talked about circumference and the distance traveled with our bicycle. Area of a circle, again, is the amount of space inside that would be covered. We want to keep in mind when we were doing circumference, we talked about the fact that the radius goes halfway across and the diameter goes all the way across our circle, and both must start the radius at the center and the diameter must go through the center. The area of a circle formula is pi r squared. Again, I do encourage you to make note cards and practice memorizing the various formulas because you will need them for the test. Our scenario for example 10 is finding the area of a circle that has a diameter of 10 meters. Round to the nearest hundredth or 2 decimal places. So as we look at the diameter, we notice that in our formula, we need the radius. So if we know the diameter is 10, half of 10 is the radius, or 5 meters. Again, we'll use our pi button on our calculator. And then we're going to multiply that times the radius squared, or 5 squared, which really means 5 times 5, or 25. I'm going to grab my calculator and hit my pi button times 25. And hopefully you got the same answer, 78.53981634. And again, I just write down all the decimal places so that you'll know if your calculator and mine are having the same answer. We're rounding to hundredths place, so 2 decimal places. We look to the number after to see if we round up. We're going to round up to 78.54 meters squared, or square meters. Again, area is the amount of space that would be covered inside the circle. All right, our application for area of a circle. How large of a cover would be needed for a circular hot tub that is 8 feet in diameter? And we're going to round it to the nearest tenth, or 1 decimal place. So again, the diameter is 8 feet. So what would the radius be? Hopefully you said 4 feet. And again, we're just going to start plugging in our numbers to our formula. Our radius then is 4 squared, or 4 times 4, or 16. And then you grab your calculator. And I got 50.26548.246. This time we're rounding to tenths place, so 1 decimal place. And we look to the number after. It is 5 or higher, so we're rounding up. And this is feet squared, or square feet for our label. Our labels are important and will be necessary on test day. Hope that you are ready to start your homework. Again, don't forget there's extra practice problems in the e-text, and the odd ones in the e-book do have answers for you. So feel free to practice, and I'll see you again in the future.